Dear students, let us continue with the third module. So in this video, we are going to study three topics, that is directory file APIs, device file APIs and FIFO file APIs. So let us start with the first topic, that is directory file APIs. A directory, what is directory? Directory contains some files. It stores a number of files, that is called directory file. So how you can create a directory using the directory API? So let me go with line by line. A directory file is a record oriented file where each record stores a file name and the inode number of a file that resides in that directory. So directory, what it contains? It contains the file and name of the file and inode number of those files which it stores. Name of the file and inode number of the file which it stores. These are the things will be stored in the directory. And directories are created with the mkdir. You might have remembered that using mkdir we can create a directory using mkdir command. Similarly, using mkdir API we can create a directories here. So let us see the prototype. Hash include sys or stat.h, hash include unistd.h. These are the main header files in which the functions are present. So integer mkdir const char start path underscore name and comma mod underscore t mode. So here the first argument is path name. So path name states where, at which location the directory need to be created, or what is the file name of the directory should be. So the first argument is the path name of the directory file to be created. It just says the path. The second argument, which is mode. So mode, it specifies the access permission for the owner, group and others to be assigned to the file. So here in mode, what it specifies? It specifies the permission, access permission for owner, group and others. What will be the permission, like read, write and execute permission, whatever. The return value, now this one, what it returns, because its return type is integer. So the return value can be 0 or -1. If mkdir creates the directory file, then it will return 1, otherwise it will return 0, otherwise it will return -1. Similarly, now suppose if you want to remove the directory or delete the directory, we can use the rmdir API. So an empty directory is deleted with rmdir API. But make sure if you are deleting a directory, nothing should be present, no file should be present in that particular directory. So the prototype for removing the directory is hash include unistd.h, integer rmdir, const char start path name. So these functions are defined in unistd.h header file, and its return type will be 0 if the directory is removed or deleted, or if any problem occurs, error occurs, then it will return -1. And it's only one argument, that is const char start path name, means it specifies the file location or directory name, path name of the directory which need to be deleted or removed from the system. So if the link count of the directory becomes 0, a link is nothing but hard link. If as we know that same file, one file can have so many names, different names, which refers the same file. So suppose 5 different names are there, but all are referring the same file. So its link will be 5. So if you delete a file, then its link will be 4. If you delete another directory, then it will be 3, like that. If the link count becomes 0, then automatically the directory will be removed. So if the link count of the directory becomes 0 with the call and no other process has the directory open, then space occupied by the directory is freed. So, and one more condition is that no other process should hold this particular directory. Then only this directory will be removed from the system. Let us study the next topic, which is called device files. As we know that whatever devices are there, hardware are there, corresponding to each hardware there is a device files present in Unix operating system. Suppose keyboard is there, so keyboard is a hardware. So corresponding to keyboard hardware, there is a corresponding device file will be present in the Unix operating system. So device files are used to interface physical device with application program. So device files, which is the soft file, it is just an interface between the physical device and the application program of the Unix operating system. A process with super user privileges to create a device file must call the mk-not ABI. So who will create the device file? A process which has the super user privilege, they can create the device file using by what API? Using the mk-not API. What are the So the user ID and group ID attributes of device file are assigned in the same manner as for the regular files. So user ID and group ID will be attributes will be assigned to the device file. Next, Unix system defines the mk-not API to create the device file. So let us see, using the mk-not we can create the device file. Let us see what is the prototype. It's a prototype is integer mk-not const char star path name comma mode underscore t mode and integer device file. Here 3 arguments are there. So first argument, it says the path name, means at which location that device file need to be created. Next is mode underscore t mode. It tells what will be the access permission for the owner, group and others to the device file. And third is device ID. So here device ID will also be there. So here we can see that mk-not scs15, we are creating a path name or device file name. Then s underscore if block means it is a block device file. S underscore if block means here device file can be of 2 types. Either it can be a character device file or block device file. So if it if s underscore if block, then it is a device file. Or s underscore irwxy means read, write and execute permission, it is given to the user. Read, write, execute permission to the group, and read, write, execute permission to the others. So this is the second argument. Third argument is the device ID, which is the 50 less than 8 to 3. Now the first argument path name is the path name of the device file, which already I told. And second argument mode specify the access permission for the owner, group and others. And also s underscore if char and s underscore if I block means if it is a block character, a block device file, this flag will be assigned. If it is a character device file, this flag will be s underscore if char and s underscore if block will be assigned. The third argument device underscore id contains the major and minor device number. So this is nothing but major and minor device number. So on success it returns 0, and if any error occurs, then it will return